Hello guys, welcome to Legacy Academy. In this video, we are going to analyze pedigree. As we know, pedigree is an important factor in genetics. So, let's move on to the topic. Before moving to the traits in pedigree, we can check some symbols that were used in pedigree. For an unaffected person, if the person is male, then we use a square shape. If the person is female, then we use a circle shape. The person's sex is unknown because the sex is not reported in this pedigree. So then we draw a diamond shape. Okay, then we can move to the next person. It is person with affected. If a person is affected, the same patterns are used, but all will be colored. If a person is affected, it is a male, then it is a colored square. If a person is a female and who is affected, then it is a colored circle. And the person's sex is unknown, then it is a colored diamond shape. Okay, now we can move to the next character, that is an obligate character. The obligate character means the carrier the gene but does not have the trait. These people will have the gene but they are not having the trait. Okay, so in this case, in the case of male, the square shape will be the same shape for the male but with a dot in the center. In case of female, circle is the shape but there will be a dot in the center. In case of sex unknown, diamond is the shape but there will be a dot in the center. Okay, now we can move to the next trait, that is asymptomatic carrier. In this carrier, unaffected at this time but be affected later, means this trait will be expressed when the person or the proband get old. So in this case, we can check how will be the symbols. In case of male, the square and having a middle line like this. In this case, male will be having a square with a middle line like this. Female have a circle character symbol and have a middle line like this. If the sex unknown, will be having a diamond shape with a middle line like this. Okay, now we can just move to the next character. If a character shown or a symbol to show a 4 peoples, so here the 4 peoples will be showing and the 4 will be male, so we can no need of drawing each 4 squares. We can just draw a square and write the how much people that number to middle. Okay, the same case for female, draw a circle and write the number how much females is there. In the case of sex unknown, the same, how much peoples will be there, that number will be writing in the middle. Now we can move to the deceased person. If a person is deceased, then the symbol will be changing, for the male, it is a band will be crossing the square with like this. In the case of female, a band will be crossing circle like this, and in case of sex unknown, there will be a band crossing like this. In the case of proband, Then what is the proband? Proband is the first affected family member coming to attention of a genetics, or if a person go to a hospital to check their genetical analysis, or whose permission we are checking a family genetical analysis is called the proband. Okay, then in the case of proband, he will be affected. So the, as we know, affected person will have a colored square in case of male. So we draw a colored square first. Then there will be an arrow indicating like this. This is the symbol for a proband, and also write a P like this. This is the symbol for a proband. In case of female, same, a colored circle first, then an arrow indicating like this, and with a P on behind it. This is a proband. In case of sex unknown, same, the diamond shape and a colored diamond shape, and with having a arrow like this and indicating a P for proband. Now we can look for the family, how we represent a family. So here this three groups, we can remove the three groups, and now we can check how we represent a family. Okay, in case of family, there will be a parent, so mother, father, and they will be married, so they will be connecting like this, and they will have three children in this family. Okay, so the third one will be a boy, and other will be a girl, and other will be also a girl. Okay, so here 1 2 and 1 2 3, this is first generation and this is second generation. Okay, so in this first generation that will be a parent, so mother, father, and here three children, a son and two daughter childs. Okay, this is how we represent a family in a pedigree chart. Now we can check the other one, that is adoption. Adoption means, as we know, if a person adopt a child, so to represent that we can draw like this. First a family and to be drawn, a father, a mother, and they have a two child, one girl and one boy. And here there is another father and mother who is going to adopt this boy child. Okay, so we will draw them in bracket and connect with a line like this. This is the symbol we used for adoption. Okay, now we can check the condition for twins. What is the condition for twins? Okay, for an identical twin, for an identical twin, there will be, the connection will be like this. If two are boys, then two square need to be drawn with this division and having a line like this here. This is the symbol for an identical twins. For a non-identical twins, we can draw like this, two squares without a middle line like this here. Okay, so here if the case unknown, it is identical or not, because it is not reported in the for the genetic analysis. So here when the data is not reported, how we could write that? It is written like this. Just draw that squares and put a question mark middle. This is the case we written for an unknown if the twins are identical or non-identical. Okay, I think you all understand. Now we can check one more character that will be showing in a pedigree analysis, that is consanguinity. Consanguinity means mating between related persons. If the mated persons having a relation, so that is consanguinity, which increase the inbreeding depression. Okay, so now we can check if a father and how it is represented will be shown here. Father, a mother of first generation. Okay, then they will have a two children like a son and a doctor. So they will be married to an external person, and here this case she is having a son, and here he is marrying to an external woman, and they are having a female doctor. Okay, then if these two are mating, so here the relation is a close relation. Only one generation or two generation gap is there, so the relation is close. Okay, so we will represent by drawing a two line instead of a single line for indicating consanguine mating. Okay, so I think that you all understood the terms and symbols were represented in the pedigree. Okay, now moving on to the each trait. We can first analyze the first trait, that is autosomal recessive trait. As per the name, it is an autosomal trait which having a recessive character. Usually appears in both sex with equal frequency, means that the both female and male have equal chance for getting this trait. This is the character of an autosomal trait. Then it tends to skip generation, means that there will be showing a unaffected persons in a generation, and following generation will having a affected person. So it tends to skip the generation. Then affected offsprings are usually born to unaffected parents. If the offsprings are affected, and if we check their parents, then their parents will be sometimes an unaffected parents. Okay, so when we see like that trait, it is the symbol of autosomal recessive trait. When both parents are heterozygous, approximately 1/4 of the offsprings will be affected. This means that if both parents are heterozygous condition, then these parents will be unaffected because it is a recessive trait and it is an heterozygous condition. So the parents will be unaffected and they will have 4 children, and these 4 children only one will have the chance to get a trait. Appears more frequently among the children of consanguine marriage. So if in a pedigree there is a consanguinity shown, this is the symbol to indicate that the trait is autosomal recessive trait. Now we can just check each character by drawing an example. For a father, a mother having a 4 children. 4 children, and one is male, one is female, the other one is female, and also last one is a male. Okay, the last one is a male. Then this is the first generation, this is the second generation. We will represent 1, 2 like this, all things. Okay, And we can see that only a male is being affected child. Then what is will be the condition? Here just we can imagine that this disease or a trait is spread by a gene A, which is represented A for dominant and a small letter A for a recessive. Okay, here both parents are not having the trait, but their one child is having the trait, means that these parents are heterozygous condition. In before we studied that when we cross-set both heterozygous, there are 4 chances. One will be completely dominant. This one will be sometimes a heterozygous condition, and 2 heterozygous condition will be there, and last one will be having both the homozygous recessive condition. Only this condition, homozygous recessive condition, will have the chance for getting the disease from this trait. Now we can move towards the second trait, that is autosomal dominant trait. As per the name, autosomal dominant trait means it is an autosomal trait with dominant character. Usually it appears in both sexes with equal frequency. So males and females have equal chance to get the trait because it is an autosomal trait. It does not skip the generation. It means that no skipping of the generation as above in recessive trait. All the individuals who have the allele will be affected because it can be causing the disease in heterozygous and even in homozygous dominant. In case of recessive condition, autosomal recessive, the heterozygous condition does not have the trait, it is the carriers in that trait. But here both will be affected. Affected offspring must have an affected parent. As above, no condition is there having an unaffected parent for an affected offspring. If the parent is unaffected, they do not transmit the trait. And one condition is that if an affected parent which is heterozygously affected mate with an parent which is unaffected, approximately half of its offspring having the chance to be affected. So we can just draw that condition, that is a male married to a female and they are having 4 children, that are 1 male, 1 female, and third one a female, and fourth one a male. Now we can write 1, 2, here 1, 2, 3, 4, and this is first generation and this is second generation. Okay, here this is an affected parent. Here the parent will have an heterozygous condition, so capital A small a, and here the female is unaffected. So unaffected parent means in a dominant character trait it is small a small a. This recessive homozygous recessive parent. So here this child will have a probability of getting capital A and small a, and this child will have a small a, and here this child will have capital A and small a, and here this child will have small a. So here this capital A small a heterozygous children will have the trait. This shows that half of the children of an heterozygous parent and a unaffected parent is affected, and this also shows that there is no difference between male and female in this trait. Now we can check the next trait, that is X-linked recessive trait. In this, the X chromosome is being affected. Usually more males than females are being affected. The affected sons are usually born to unaffected mothers, thus the trait skips generation. Approximately half of a carrier mother's sons are affected. Never passed from father to son, because father gives Y chromosome to son. All daughters of affected father are carrier. So we can check a condition of this by pedigree chart. Before that, this chromosome will be represented like this: XA for dominant allele and X small letter a for recessive X chromosome. Okay, a heterozygous female married a normal man. So here the condition will be XA, X small letter a, married a normal man, means X capital A and Y. They had 2 children, both are male, and the chance for is a heterozygous mother will is 1/2, so it's half of one male will be a affected one and the other will be non-affected one. So the affected male have a chromosome like X A Y and here X capital A and Y, because only Y chromosome is being provided by the father. The next trait is X-linked dominant trait. Here the sex chromosome X being affected in dominant allele. Both the males and females are usually affected. Often more females than males are affected. Does not skip generation. Affected sons must have an affected mother, and affected doctors must have either an affected mother or an affected father, because doctors get X chromosome from both father and mother, and sons only get X chromosome from mother. Affected father will pass the trait on to all their daughter. Affected mother, if heterozygous, will pass the trait on to half of their sons and half of their daughter. So here we can check a condition. A non-affected female means it is both recessive condition female married to an affected man. Here when an affected man means here the X chromosome XA and Y and affected man. Okay, then they will have 2 children, and one is female and other is male. Here there is no chance for male to be affected because his mother is unaffected, so he get an recessive X chromosome from mother and a Y chromosome from father. But here the girl will be affected because she get a dominant X chromosome from father and a recessive X chromosome from mother. As the dominant X chromosome dominate the recessive one, then the girl child will be affected. In a Y-linked trait, only Y chromosome here being affected. Only males are being affected in this trait. It is being passed from father to all the sons. There is no skipping in generation. So we can check a pedigree. A mother always will be normal in case of Y-linked trait. Married an affected man. So here the X will be normal and here XY will be affected one. Okay, then they having 2 children, one girl child and a boy child. There is no chance for the girl child will be affected because it is not linked by X chromosome, but there is a chance, there will be a chance for the male child to be affected because only the Y chromosome is being provided by father, not by mother. So in Y linked, if a father is affected, his son will be affected. Now we can analyze a question. An analysis of 4 microsatellite markers was carried out in a family showing a genetic disorder. The results are summarized below. Here, an affected female married an unaffected man, and she has 3 affected females and an affected male and then 2 unaffected male. And here the shown a chart of markers corresponding to these traits and persons. So when we compare these two charts, we can see that there is a 2 band in M2 and M4 position for P1 and 2 band in M1 and M3 position for P2. So here the question is, based on the above, which of the marker shown shows linkage to the disorder? Okay, for this question, the technique to crack this question is, we want to check which all the persons are having the disorder. Here P1 is having the disorder. So we want to check which all band it gets. In P1 we get band at M2 and M4. Then we check the next disordered person. It is 1. 1 get band at M1 and M2. Then the second one is, second person is also been affected. So he get band at M2 and M3. And the fifth person is affected and he get banned at M2 and M1. The sixth person is affected and he get banned at M2 and M3. So in all these conditions, the M2 is the common one. So the M2 is the marker showing the linkage of to the disorder. And we, for confirmation, check with P2, 3 and 4, we could not see a band at M2 position. So this shows that M2 is the marker showing linkage to this disorder. Now we can check the next question. What is the probability of getting third generation first person to have trait if the following shows an autosomal recessive trait? In this first generation, parents can be heterozygous or homozygous dominant because it is an autosomal recessive trait and they are not affected. But their a child have been affected, so they will be a heterozygous condition. So we can write capital A, small a for all the parents. Okay, in both families, and this affected child will be small a in both family. Okay, now we need to know second generation, second one. What are the possibilities? It can be capital A or small a capital A or capital A small a, because it cannot be small a because it is not affected. What is the probability of second generation third one? All the probabilities are same. Capital A, small a capital A and capital A small a. So what is the probability of getting the third one affected? Okay, in this case, if the third one is being affected, then the second and third of second generation need to be heterozygous ones. Okay, then what is the probability of second generation 2? That is 2/3. Then what is the probability of second generation 3? That is also 2/3. Now, what is the probability of getting this one, third generation first one, a small a condition? The probability is 1/4. How it become 1/4? Because for third generation first one, there are four basic probabilities that are small a, capital A, capital A, small a, capital A, and capital A, capital A. Okay, so in this one need to be, we need, so it is 1 by 4 is the probability. Then by applying AND rule, if you don't know the AND rule, our earlier video we have discussed about AND rule and OR rule in probability of Mendelian genetics. Okay, by according to the AND rule, we multiply all this one, 2 by 3 multiplied by 2 by 3 multiplied by 1 by 4. Then we get 2 times 2, it is 4, then 4 by 3 3s are 9, and 9 4s are 36. It is 2 times here and here, 1 8, then 1 9. Then the answer is, probability is 1 by 9. And that all about pedigree analysis. I hope you all understand this video. So please like, share and subscribe our YouTube channel and follow us on Instagram. Lagos Academy, your educational catalyst.